Hello, Professor McMath here, ready for another exciting video. Today we're talking about nth roots and rational exponents. So the idea of the nth root, this is dealing with other concepts besides square roots. So the nth root, very straightforward. If we have a to the n power, then a is the nth root of b. Example of this meaning, so if we raise 3 to the 4th power, we get 81. That implies then the 4th root of 81 is 3. So for this particular video, we'll be discussing only perfect nth roots, so 4th root of 81, 3rd root of 8, 5th root of 32, stuff like that, things that are perfect roots. So if we want to simplify them, number-wise, pretty straightforward. We have the 4th root of 16. Well, we have to ask ourselves, okay, what raised to the 4th power is 16? That's just 2. And as far as variables with exponents, the way we handle simplifying them with our nth roots, we just divide the exponent by the root. So since we have y to the 8th, and that's the 4th root of that, we do 8 divided by 4, and we get 2. So it's y squared. For the 3rd root of 27, again, that's just 3, because 3 cubed is 27. And then for both the x and the z's, we divide the exponents by 3. So 9 divided by 3 is 3, so it's x cubed. 12 divided by 3 is 4, so it's z to the 4th. And then again, 5th roots, same idea. So 5th root of 32, what number raised to the 5th power is 32? That would be 2. And then for each of the exponents, we now divide by 5. So a squared, 10 divided by 5 is 2. B cubed, because 15 divided by 5 is 3. And then c to the 4th, because 20 divided by 5 is 4. So again, if we're simplifying these roots, with we're just simply dividing the exponents by the root. It's very straightforward. And again, for right now, we're only focusing on perfect roots, so they should be a nice number. You can think of small number raised to that power that gets us the inside number. In a future video, we will discuss how to simplify like the 5th root of like 24, for example, and how to work with that. Now, sometimes we need to use the absolute value sign with these nth roots. This will occur only with even roots. Don't need to worry about odd roots. And this is after we take care of that, the result is an odd power for the variable. We then need to use the absolute value sign to ensure the number is non-negative. This is because, so like for example, if x was -1, if we're doing the 4th root of -1 to the 12th power, well, -1 to the 12th power is just simply a positive 1, and the 4th root of 1 is just 1. But if we use the x cubed value, the result from this, -1 cubed is -1, so those two numbers don't match up. That's why we have to use the absolute value sign. Again, it only applies with the even roots, because an odd root we're allowed to have a negative result from it, so it's no big deal. But even roots can only result in positive numbers. To ensure it stays positive, we apply the absolute value sign. Don't need to do this for everything, only when it's an odd power from the even root. So for this one right here, we have 16x to the 4th. We're doing the 4th root of that. So the 4th root of 16 is 2. And then 4 divided by 4 is 1. Since that's an odd exponent, we'll have to do the absolute value of x. So 2 absolute value of x would be the answer here. For the next one, it's the cube root. So since it's an odd root, we don't need to worry about absolute value. We just go through it the same way. So the cube root of -64 is just simply -4. Again, unlike our square roots, which had negatives involving i's, or even roots, which can't have a negative number inside. Anyway, odd roots we're allowed to have that, because that's okay, because odd numbers raised to odd powers will stay, negative numbers raised to odd powers will stay negative. And then for the variables, again, we just divide by the root. So 9 divided by 3 is 3. 15 divided by 3 is 5. And then 12 divided by 3 is 4. Again, because it was an odd root, I don't need to worry about any absolute value signs here. And then our square root of 49 is just simply 7. For the d, 8 divided by 2, because even though it's not there, that's what the square root is. It's a 2, a second root. So we just do 8 divided by 2 and we get 4. That's even, so I don't need to worry about an absolute value. But for the f, 6 divided by 2 is 3. So I need the absolute value of f cubed. Again, only need to worry about absolute value when it's in even roots, and when it's an odd exponent resulting from that. So that's why the odd root for the second example there, didn't need to worry about it. And that's why for that last example, d to the fourth, I don't need it because the 4 is an even power anyway, and we don't have to worry about negatives because of the even power. Now, a rational exponent is essentially what is really happening here, because this radical symbol is just simply the mathematical symbol we're using for the idea of a fraction exponent. So in general, b to the xy, the denominator of the fraction for the exponent, is the root of the radical, and then the numerator is just simply what we're raising the inside to. So b to the xy becomes the y root of b to the x. This works every time except for when b is both negative, less than 0, and the y is even. Because again, we can't take an even root of a negative number. If b was negative and it's an odd root, no big deal. We're allowed to do odd roots of negatives. A complex root may exist in those cases if b is negative and the y is even roots. So always watch out for that. Remember your i's with the square roots. There's technically other ways to write that if it's a fourth root and it's a negative inside, but we're only going to focus on square roots with I. So we want to rewrite each one of these expressions in terms of the opposite form, meaning if it's an exponent, we're going to write it as a radical. If it's a radical, we're going to write it as an exponent. So 4 to the 2/7 power, well again, the denominator of the exponent is the root, so this then becomes the 7th root of 4 squared. Now, so 4 squared is a simple number. We can say that's 16. So this is just simply the 7th root of 16. Can't do anything with it. This is the lone exception to when I said these are going to be perfect roots here. We're just simply rewriting them. So as long as we put it in the simplest form, we don't need to worry too much about this. Now when I raise exponents to another exponent, we still apply those basic rules of exponents. We multiply them. 3 times 3 halves becomes 9 halves. So then this means, again, the denominator is the root. So it's a second root of x to the 9th, which a second root is just simply a square root, so we can write it without that 2 symbol. So it just becomes the square root of x to the 9th. We can leave it in that form. Technically, there's ways to simplify it from there, but again, we're just simply rewriting it as a radical. We're not trying to go too crazy with this. So the 4th root is 63. Well, that just simply becomes 63 to the 1/4 power. 63 is raised to the 1st power, that's why there's a 1 in the numerator spot. It's a 4th root, that's why the 4 is in the denominator spot. Now for this last one, and because 63 was a non-perfect 4th root, we don't need to worry about trying to rewrite it as a whole number. But for this next example, 625, that is a perfect 4th root. So if we rewrite it as 625 to the 1/4 power, we will have to evaluate that. And then we have x to the 2/4 power. Well, the 4th root of 625 is actually 5. 5 to the 4th gets us 625. So that's why this becomes 5. And then for the x, well, we should rewrite that because 2/4, as always, we should always reduce our fractions. So that becomes x to the 1/2. Alright, so again, this exercise we're just simply rewriting our rational exponents. There's ways we can work with them in terms of solving equations, and we'll talk about that in a later video. And that's where you'll generally see a lot of times these rational exponents. Beyond that, just simply know what they are and know how to rewrite them to work in other forms, and so that if you encounter that on a future question for a future video, or if you encounter that on something like the SAT or the ACT, you have an understanding of what's going on. Alright, so that's all I've got for you today regarding our nth roots and rational exponents. Again, thank you for watching. And McMath is out.